So my name is Sushant. I'm a software engineer at Google. I have completed a master degree in computer science from IIT Bombay, and I have around 7 years of experience, both in software engineering and machine learning. Okay, so I'm going to solve this problem. This problem is called modified Fibonacci, and I guess the only modification I see here is you have to square the second term. So I guess most of the people will be familiar with the Fibonacci sequence. It's a simple sequence where you add previous two terms to get next term, and you keep doing that till you get the nth term. So in this problem, I see that you are given two terms, ti and ti plus 1, and you have to compute ti plus 2 till you get to the n. So yes, you are given three integers, t1, t2, and third integer n. You have to compute and print the nth term of the modified Fibonacci sequence. So the input we are going to get is t1, t2, and n. So first you need to tell the approach to your interviewer. So I guess the approach here is pretty simple, that you are going to get two numbers which will give you a sequence. So these are the two numbers, 0 and 1. They have given a simple input. So from 0 and 1, you need to continue the sequence till you get 5 numbers. So in the example, they have given that it continues from 0, 1 till you get the fifth number. So I guess we need to start from the second number. So 1, 1, 2, 5, then 27. Okay, sorry. So you need to start from the first number. So 0, 1, 1, 2, 5. So fifth 5 should be the output of this input. So approach is pretty simple. You are going to continue calculating the new term and use that new term into the equation again. So this is the equation. So you are going to calculate ti plus 2 and then going to use that ti plus 2 in the place of ti plus 1 and ti plus 1 in the place of ti. So this sounds pretty simple, and that loop is going to continue till whatever the number you are getting here. So that will be our approach. Can anybody tell me that is there a classic algorithm that this problem reduces to? Yeah, okay. So Ashutosh is saying it's a simple recursion problem. Yeah, it's a recursion problem, but I just wanted to know which classic algorithm this problem belongs to, whether it's a divide and conquer or whether it's a greedy. Okay, he's saying that it's a greedy. Okay, let's solve the problem, and then we can think that which classic algorithm that this problem belong to. Let's code first and then move on to optimal solution. There is one optimal solution for this problem also, because if you keep continuing this operation, you will very soon run out of memory, or maybe the complexity will be too high. So let's just code the solution first. So in Python, it's pretty easy to get input. So we have three numbers here. So I'm just going to say that is t1, then t2, then n, and whatever the input we are getting. So input will give us a string. We need to split it. So we are going to split it. So and then we are going to map an int on them. So we are gonna get in three integer variables here: t1, t2, and n. And we need to continue till nth term. So let's just put a for loop. We are going to run a loop till n, and we are going to calculate a new value. So say that I'll just rename them to 0 and 1, and they're going to be t2. I'll keep that 0. In the start of each loop, we are going to calculate t2, that is addition of t0 plus the square of t1. So t1 star t1 is a square. This is the formula that they have given here. It's a modified Fibonacci sequence. So instead of writing just t0 plus t1, we are writing t0 plus t1 square. So we are going to get t2, then we are going to replace these values. So we are going to say bye bye to T0. So we will replace the T0 with T1 and then T1 with T2. And then we are going to print whatever the value of it will be T0, I guess. Let's just run this code. So we are getting error that int object is not iterable. Yeah, I forgot it. You have to put a range here. So range converts your integer to a list. Then you can iterate through a list. Okay, I'm getting a wrong answer because I guess I'm printing T0, or maybe I'm going to one loop further. Okay, so this is a basic solution. Yeah, so we are done with the approach, basic solution. We haven't done error handling, boundary value analysis. We haven't done testing because it's a hacker rank. They are testing for us, but in normal interview, you won't get hacker rank or any IDE. So you have to test it for you. If the first I run the algorithm, the code with n, right? So that way I got wrong, and then I figured out that it should be n-1. While coding, you need to focus on each thing, each numbers, like is the loop should run 5 times or 4 times. So it should run 4 times because we already have T0 and T1. We calculating T2, so it shouldn't run 5 times. It should run 4 times. So for n, it should run n-1 times. Once you increase a number too high, so see this number, to calculate this number, I mean it's calculating now because n is only 10, but if n runs to 100 or 1000, this solution is not going to work. We are not caching, we are just running to n, and we are not even using the previously calculated values. So instead of just doing this, what we can do, we can create a table. So I say it's a table, and I'll say that it's a list. And every time I'm calculating a new value, I'm going to store it in that table. For table 0, so in table, we are going to store first T0 and T1. And when we are calculating T2, we are also going to store it in the table. Now we need a loop variable because we are going to index the table here. So say the loop variable is I, and it should run from, because we have already used index 0 and 1, it should run from 2 to n+1, because then loop will run from, so the loop is going to still run till n-1 times, but the index have changed, so it will run from 2 till n+1. And we can index the table now because we are using a induction variable, and we are just going to store the T2 value here. Now in this particular problem, you won't see any usefulness of this table, because the problem is it will only provide 3 integer values and you have to give only one output value. But say that the problem give you multiple values, in that case you have to keep on calculating the values each time, so the complexity will increase. So instead of calculating value each time, you can just refer to the table. If the value exists in that table, then you can just throw it out. So instead of using T0 here, we can access the table here, and in table we can just throw out n-1 value. I guess this should work. I forgot you can't access the table this way. So let's just create a table with the allocated memory. Let's say it's 0. Yeah. So I'm actually accessing a table where I already stored the value. You won't say that complexity has been reduced. I won't say that complexity has been reduced, but say if you got multiple inputs, like you are getting 100 inputs, So with the same initial T0 and T1, you won't have to calculate the nth term each time. So you can just refer to the table. If it has been calculated, it will show you the output. Yeah, so Sunny is asking a question. At the time of the code round, they provide any ID like HackerRank, or they expect a correct code on a whiteboard itself? Yeah, so it depends on the company to company. Most of the company don't provide any ID when we are in face-to-face round. They expect you to write a correct code on the paper or whiteboard itself. They don't focus on the syntax, but they do focus on the logic. So if you miss a spelling, or if keyword is not there in the language, that is not a problem. Yeah, you can't be sure of the whether program is the correct or not. Yeah, that's the thing that you have to practice for that. I will say that you should practice on the board rather than ID, because the ID will be usually in the first or second round, but when it comes to the face-to-face round, it will be usually on the whiteboard or the paper. And someone is asking best language for a whiteboard. Throughout my career, I've found that Python is the best language for competitive programming. If you write this program in C or Java, it's going to become too big. This problems actually comes under dynamic programming, because I'm using a table. You can see the table here. I'm caching the values that I'm calculating in between in the loop, and I'm caching them. So algorithm selection was dynamic programming. Data structure was there. We used an array. Table is actually an array, or you can call it a list. So this is an array of size n+1. This was our optimal solution. We used a table instead of just going every time through loop. We can just use the table. So because this operations will happen till n only, you can say it's O of n complexity. But when there are multiple inputs in the same program, once you get 100 input in the first test case, and if all the other test cases are less than 100, though often complexity will only apply to the first test case, then all the test cases is going to be constant time, because the values has been already calculated. We haven't done error handling here. We don't know what happens when the input is like 0 or maybe a negative number. We haven't done that. You should do that in an interview question. Error handling and boundary analysis is kind of mixed. Do boundary analysis, like you should test your program for a very large input or very small input, maybe fractional input. All those things comes under boundary value analysis and error handling.